Once you identify the target bottlenecks and fix them, and if you do not find any problem with the targets, then come back to source. So then start identifying the source bottlenecks. Again, the same way. First is that put a filter transformation. The moment, okay, let's take an example. If you have a database as a source, either you can do either you improve the query of the database. And how you can improve the query of the database: whenever you are using a database and writing the SQL override, you have to make sure that if you have a joins, you create the indexes on the joins. If you have primary keys in your source, you create the indexes on the primary key as well. That's very important. How you can improve your database query? Let me write it here. By adding the joint, by adding the indexes on primary keys and join condition columns. So this is very important. Have your DBAs to create indexes on your primary keys as well as on the join condition. And apart from that, ask your DBAs to create indexes on the entire SQL. Another option could be, one second guys. Okay, so the another option is run the query in different modes. So when I say different modes, so mode means basically, let's say you have 100 records, 50 records, 50 even records you run in one flow, 50 second odd records you run in the other flow. So basically you're not going to run 50 and 50 sequentially, they will run in parallel, but you create the mods, you apply the mod function in your query and run them in the parallel. So that is how you can improve the performance of the queries by implementing these simple techniques. So these are pretty important. And apart from that, coming back to the filter transformation, so how you are going to use a filter transformation. Let's say you have the database as your source. Remove the database, or don't remove the database, put a just filter condition and make it as a false. So let's say your job was taking 10 minutes to read the data, or basically to run the entire ETL. If even after adding the filter transformation just after the source transformation or your source qualifier, and you have enabled the false property into the filter transformation, which means that no record will be moving to the next transformation, every record will be filtered there itself, all the records will be filtered because you have enabled the false option. So if the job is still taking the same time, so it means there is a problem with your source, because you are not moving the data to the next transformation, everything you are filtering, and if the job is taking the same time, it means the problem is with the source, right? This is how you will identify the source bottlenecks. And once you identify the source bottlenecks, now you know that how to fix them. First thing is that have your database admins to optimize the query, which we just discussed in the previous slide, how we are going to optimize the queries. The second option is that basically increase the database network packet size. This is again DBAs can help you configure the index and the key constraints. So when you are reading the data from the source, you must have the index on the key constraints, as well as you should have the constraints, primary key, foreign key. Apart from that, you must have the indexes on the constraint as well as on the tables. This is how you can eliminate the source bottlenecks. And then once you identify, okay, the source is also good, you have fixed the source as well, then moving to the mapping transformations. Different transformations are there. First, again, how to identify the bottlenecks. Go with the same thread approach, where we have already seen like there are different threads. One was the writer, then the third one was the other one was reader, and the third one was basically the transformation thread. And in the threads, you have to identify which particular transformation is taking more time, or which transformation is keeping the system more busy. Okay, so once you identify the threads also, and if that is going to work for you, it is good. Otherwise, there is one more approach to identify whether your mapping or basically the transformations has a problem or something else is going wrong. What you have to do, you have to add the filter transformation before the target definition, so that the no data will be loaded into the target. And if your job was taking 20 minutes to load the data into the target, and if your job is still taking 20 minutes not to load the data in the target because now you have added the filter transformation which will not load the data, it means the problem is with one of the transformation, because the time while loading the data into the target and without loading the data into the target is still same. It means there is a either problem with the source or there is a problem with the other transformation, but not with the target. Okay, so there are different ways like how you can optimize your mapping or other transformations. The first and more important is that basically, let's start with this. You apply the filter transformations appropriately. Whenever you want to filter the data, you do it immediately. Make sure that you do not do the data type conversions too much and optimize the data type conversions. And factoring out the common logic. So factoring out the common logic means if there is a common logic, try to create a single maplet instead of writing the same logic again and again into the different mappings. The next is my favorite one, aggregate the function calls. So let's say you have column A and column B, and again then you are doing the sum of column A and column B, and then again doing the aggregation. Instead of writing your code in this way, write the code in this way, you'll get the same output. And whenever possible, try to have the numeric values for the comparison instead of the string. So when you're trying to compare two functions, the function or the column which has the numeric value, use that particular column for your comparison instead of the string column for the comparison. And whenever possible, instead of writing the lookup transformations, if your values are small and if you have a very limited number of values, use the decode function instead of joining with the lookup table. And whenever possible, try to concatenate the data with the help of pipelines instead of using the concatenate function, because a function will again take your memory and it will consume everything. Instead of that, try to use the operators. So this pipeline symbol will help you to again concatenate first name and last name instead of using like first name and last name with the help of concatenate function. And especially whenever you're writing the if function, if else function, so that is pretty important. If you see this example, in this example what I'm going to do, I have a 3 flags, flag A, flag B and flag C, and if any of the flag has a value as a Y, I'm going to add that value. So here if you see carefully, flag A has a value Y, flag B has a value Y, flag C has a value Y, so I'm going to add A, B, C. So if flag A has a value Y, flag B has a value Y, but C doesn't have value Y, so I'm going to just add A and B. So similarly, I'm going to make all these different combination and I have to write the if condition 8 times. But instead of writing the if condition 8 times, I can achieve the same result by writing just 3 times. If flag A is equal to Y, then value of A, else 0. If flag B is equal to Y, then the value of B, else 0. If flag C is equal to Y, then the value of C, else 0. So this is the way that you should be writing your if else conditions in the mapping or in the expression transformations. Okay, and apart from that, if you are using the aggregate transformation, try to use a group by with the simple columns. So when I say simple columns, basically let's say you have employee table, so try to group the data based on the employee ID, not with the employee name. Employee name is having again string values, employee IDs is still numeric values. It can be a alphanumeric values as well, but it's still a simple column. Try to send the sorted input into the aggregate transformation as much as possible. If possible, try to use an incremental aggregation. That's a separate topic. It may or may not be applicable every time. If you are able to filter the data before you aggregate it, that's well and good. And limit the port connections into the aggregate transformation. If you do not want to aggregate every single column, do not pass even those columns into the target aggregate transformation at all. Similarly, if you are using the joiner transformation, so there are a couple of options like how you can improve the performance by using the different techniques while using the joiner transformation. First thing is that you will have to select your master and slave, parent and child table. So select your master table or master source table which has a less number of duplicate records. That should be your first approach. Second is that a table which has less number of rows, that should be your master source. The first one was that select a source as your master which has a less duplicate keys. Second is with the less number of records. The third is that if it is possible to perform the join at a database level, do it at a database level instead of using the joiner transformation at all. And if not possible, then of course you have to use the joiner transformation. And apart from that, join whenever you are sending the data to the joiner transformation, try to send the sorted data. So that really helps to improve the performance. There is a property at a session level where you can actually click on that property and you can select that whether the data is sorted or not for the joiner transformation. And if the data is not sorted, and if you will select that sorted option, the job will fail as well. So you have to be very careful when you are sending the data to the joiner transformation as a sorted data, then only enable the sorted option at a joiner transformation level. Yeah. Next is optimize the lookup transformation. So lookup optimizing the lookup is very important, because what happens, so sometimes the lookup tables have millions of records and your source is just sending 10 or 20 or 100 records, and for those 100 records you're going to look up the entire table which has a millions of record. So that is the biggest bottleneck. So you have to make sure that when you send the data to the lookup transformation to look up the related data, you try to restrict the data by overriding the SQL. You need to have a join in your lookup transformation with your lookup table as well as with your source table what you are sending to do the lookup. Try to have an inner join so that the data itself is restricted before the lookup. Now you do not want to look up into the millions of records. You should be able to look up on just only 100 or 1000 records which you are sending it to the source, so sending from the source. And apart from that, you have to make sure that you use the appropriate cache types. If possible, enable the concurrent caches. Optimize your lookup condition. Try to send the conditions, try to send those columns which have the numeric values, and override the over by order by statement. If you do not write the over by statement after your lookup SQL, what happens? So by default, lookup transformation use all the columns in ordering the data, but if you will override the order by, it will only order by the records whatever you will mention in your statement. And try to use a machine with the more memory, of course. Okay, once you have identified your target bottlenecks, source bottlenecks, mapping bottlenecks, then comes to the sessions. So basically you can't do much at a session level, but only thing is that you have to see what are the different properties at a session level you can see. And for identifying the session bottlenecks, what you have to do, you have to go to your workflow monitor, and in the last at the bottom of the monitor you will be able to see about all the performance detail about each transformation, the number of input rows, output rows, and if there are any error rows. Based on that, you will also be able to identify, okay, what needs to be fixed and how you can identify and fix your session bottlenecks. Okay, moving to the next slide. Try to run the concurrent sessions and workflows, and if concurrent sessions and workflows are not possible, then at least whenever you are writing the sessions in the sequential way, make sure that they are all properly optimized. Yeah, so this is the end of this particular session. I hope you guys enjoy this video. Let me know if you have any questions, concern, leave a comment for that. Thank you.